Hello everyone, I'm Will Hout from Butterfly Data and I'm excited to share our project from this year's hackathon, Combating Misinformation with Trusted Data. With the flood of news, misinformation and disinformation are becoming major problems, often influencing decisions and causing harm. In fields like democratic elections, misinformation campaigns aim to sway opinions. Analysts spend too much time verifying data sources, trying to identify unreliable information and ensuring they're using reliable information instead. We wanted to develop a tool that would aid analysts in identifying misinformation with transparency at its heart. At Butterfly Data, we're committed to ensuring insights are based on trustworthy sources. That's why we developed a tool that uses advanced NLP and classification models to check the trustworthiness of open source data. As a B Corp certified company, putting people and planet first is part of our mission. We aim to help others make decisions based on reliable and ethical data. Our tool analyses the trustworthiness of news sources, calculating a trust score using classification models. An LLM provides explanations which are displayed in a dashboard, helping users make informed decisions. To create this solution, we used agile methodology and leveraged SAS Viya, Workbench and Copilot, along with open source tools like Git, Python and VS Code for collaboration. Having centralized data in SAS ensured our models and dashboards were always accurate and up to date, allowing us to maximize the use of information data catalog and its APIs to show lineage and data quality information. This enhanced the transparency and meaning users could understand the origin and reliability of the results. Now, I'm excited to share with you the results of our hack.
To prepare the dataset, I started off with adding the labels to the data and merging the data into one table. This is the table that I achieved after preparing the data and following all those cleaning steps. SAS was great for this project because it offered flexibility to switch between different languages, SAS for data preparation and Python for model training. It also integrated well with various data sources, allowing us to efficiently clean and handle large datasets. After testing few models, the SVM showed the highest accuracy. It's a robust classifier, especially for tasks where we want to draw a clear line between two classes. SVM excels in high-dimensional spaces, which is exactly what we deal within the text classification. When we apply vectorization to our text, each word or token becomes a feature, and this creates a large number of dimensions. I tested it and analyzed the results using the classification report, confusion matrix, comparing the true and predicted labels. These numbers basically tell us how well the model is performing. We also checked the confusion matrix, which shows the number of correctly and incorrectly classified items.
I explored the capabilities of SAS by implementing logistic regression, initially splitting existing data into test and train, and then creating token features such as counts and lengths. And then I applied the logistic regression model commonly used for NLP tasks. We can see that the results for this model were kind of half-half. In some cases, it performed very much better. I was also working on a Python code for a more sophisticated model.
Large language models, or LLMs for short, are a very powerful tool for natural language processing, especially in the case of fact-checking. They're very useful for understanding, comparing, and summarizing text. I've created a Python script that interacts with the Google Gemini's LLM using its API. It takes statements from a dataset and fact-checks them using the API. It then stores the response it retrieved from the LLM into a SAS database. The LLM has accurately summarized what the statement has said and why it's partially true and partially misleading. I used to create this request to the LLM API. It takes 3 statements, passes it to the LLM through its API, and then it stores the resultant responses in the fact check table. Despite this amazing performance, some clients might still want to perform fact checking using their own set of ground truth documents. I created an LLM RAG system just for this task and stores them in a phase vector database for ease of retrieval. The statement and the context are sent to the LLM via an API call. The LLM response can then be put into a shared database that it can be accessed by the wider system. I use SAS Viya Workbench for this extension. Here's an example of a prompt that I sent earlier. The meaning of witchcraft was written by John Bobson. The LLM says this was incorrect because it was written by Gerald Gardner. It's returned the URL corresponding to the top ground truth documents it found related to the statement.
In Model Studio, and then I added in these text mining nodes as well. And this model took about 20 minutes to train. And as you can see, it's trained 6 different types of models of neural networks: stepwise logistic regression, forward logistic regression, decision tree, gradient boosting, and random forest. And at the end, when I saw the model comparison, this was 97.6% accurate. To pull all of our analysis together, we decided to use SAS Analytics to make a dashboard. So on the screen, you can see our summary page, and this allows the user to see a history of all the articles that they've checked for trustworthiness. So on the left, we've got a pie chart showing the split between articles that have been flagged as trustworthy and those that have been flagged as fake news. On the right, we've used text topics visualization to do some topic modeling, some sentiment analysis, and we've also produced a word cloud. So what's cool about this is we can filter by the pie chart on the left. So if we select only the data that's been flagged as true, then you'll see that generally there's some words in there that are not really too specific. There's nothing that's standing out as particularly negative. And interestingly, we've got a word in there like life and a word like help, which generally are quite positive. And if we switch to the fake news, then what we can see in here, we've got a lot of words that are generally trying to elicit some sort of reaction out of you. So another piece of filtering we can do with this page is we can click on each of these topics that have been selected, and what will happen is the word cloud will update, and also the documents list at the bottom will update. So you'll see the relevance to the topic you've selected on a document by document basis. You'll also see the sentiment score. So you can see here the word cloud's updated. So the second page of our dashboard allows the user to go in and see in a bit more detail why their document has been provided the score that it has been. So on the right side, we've got the output from our support vector machine. This is providing the user with a trustworthiness score. And in this summary column, we've also got the summary that's provided by the LLM that explains why this particular article is trustworthy or not. There's one here about a flesh-eating disease in America. The writer is trying to make the claim that Syrian refugees have brought that into the country, and the LLM has looked into this and has replied to say that some elements of this document are accurate, while others are misleading or lack context, which I think fits quite nicely with the SVM coming out with a probability of 30%, which would imply that there's maybe some truth to this, but generally it can be quite misleading. Every time that we're filtering this, you'll see that the article at the bottom is updating, so you can have a read of what has been fed. You haven't got to go back and look for that original source.
As part of our solution, we wanted to ensure data governance was at the heart of all the decisions that were being made. We used SAS Information Data Catalog to be able to show the user within the dashboard key pieces of information, such as the tables that were being used, the type they were, when they were modified, and when they were created. In this page, you can see all of the tables that we used in either the models or the dashboard.
In a world where data can shape decisions with real-world consequences, it is essential to ensure its reliability. Our project offers a practical solution to the growing problem of misinformation, helping analysts and decision-makers use trustworthy information in their work. We believe this advanced NLP tool can be a powerful force for good, helping to combat disinformation and promoting a more transparent and informed world.